Hi, Mr. Corsi here. This video covers the SQA National 5 Maths Paper 2 from 2025, and I go through all the solutions to the questions in detail. Now you can scroll along the timeline that's below the video to get to the particular question you're interested in, and I hope you find these solutions are useful to you. So here we have question 1. We're told the number of visitors to a zoo in 2024 is 118,750, and we're expecting that number to increase by 4% for each of the next 2 years. And we're asked to calculate the expected number of visitors by 2026, that's 2 years later. So we're looking at the 2024 figure, which we know is 118,750. And to get the 2025 figure, we have to increase that by 4%. We have to add 4%. Now, one of the ways of doing this calculation, is multiplying that figure by 1. That keeps the whole thing. 0.04, which is 4%, it's 4 hundredths, and that will give us the required answer for 2025. And likewise, when we travel on to 2026, we have to take the 2025 number, whatever that is, and add 4%. In other words, take the 2025 number and multiply it by 1.04. And that will then produce the required figure. So the number of visitors, we now have the calculation that we should be doing. The number of visitors is the 2024 number, that's 118,750, and multiply that by 1.04, in other words add 4% to it to get the 2025 figure, and then multiply that by 1.04. Increase that one by 4% to get the 2026 figure. So that's the calculation that we've to do. So let's bring on the calculator to do that and enter in the numbers. So there's 118,750. Multiply that by a factor of 1.04. and then multiply that by another factor of 1.04 and press the equals key, and there we go. It's 128,440. So here we have question 2. We're told that shops selling footballs and that they have a diameter of 21 centimetres. We're asked to calculate the volume of one of these footballs, giving our answer correct to 3 significant figures. Now, if you look at your formula sheet that you're given during the exam, there is a formula given there for the volume of a sphere. So that's what we use. We'd use V equals 4/3 times pi times r cubed. And the only thing we don't know is the radius. Well, we know that the diameter is 21, so the radius of this football is going to be half of that. That's 10.5 centimetres. So that's the radius. So the calculation we have to do is 4/3, 4 divided by 3, times pi times 10.5 cubed. So let's bring on the calculator to do this. So calculator, 4 divided by 3, 4 divided by 3 times. Now, pi button, you'll know where your pi button is. Mine's tucked away down here and it's above this key, so I have to do a shift first and then press the button. That gives me my pi times 10.5 and cubed. Now, you'll know your calculator. I have a squared button. Some calculators have a cube button, but this is my raising to the power button here. And when I press that button on the display, it's asking me to fill in the power that I want to raise 10.5 to, which is 3. But you should know on your calculator how to get the cube of a number. So there it is. We'll finally press equal, and there's our answer. So that equals 4849.04, and so it goes on. Now, the accuracy, that's approximately equal to 3 significant figures. So that's 1, 2, 3, 4, 8. But if we're using this 4, we're chopping off a 9, so the 4 goes up to a 5. So that's 485. To show it's in the thousands and not the hundreds, we have to add a 0 on. Measurements, lengths are in centimetres, volume will be in centimetres cubed. I better say what we've done vandalising that number. It's to 3 significant figures. So there we go. The volume of that football, 4,850 cubic centimetres to 3 significant figures. So here's question 3. We're told the mass of one atom of gold is 3.27 times 10 to the power negative 22 grams. This, of course, is in scientific notation. It's a terribly, terribly small number. And to write that out fully, you'd have a 0.000, loads and loads of zeros. So scientific notation, a method of writing these terribly small or terribly large numbers in a more convenient way. And we're told that the mass of one atom of carbon is 6.1% of this figure, the mass of one atom of gold. And we have to calculate the mass of an atom of carbon. So we have to work out 6.1% of this figure, giving our answer in scientific notation. So the calculation is 6.1% of 3.27 times 10 to the negative 22. So let's just go to our calculator and see if we can get that done. And here's the calculator. So what I'm going to do is I'm going to do 6.1%. That's 6.1 divided by 100. So that gives me my 6.1% times, and I've now got to enter this number into the calculator. There's several ways of doing that. If you know the mode on your calculator that allows you to enter scientific numbers in scientific form, then that's terrific. And mine, it involves this button exp down here. So in my case, I would write 3.27 and then press this X button and get an E, capital E on the display, and then put in negative 22. Now watch out for this. Negative is not the same as subtracting. That's my negative key here. You'll need to find out in your calculator whether you have a key similar to that. That's my negative button. So I would press that and then 22. So there's me entered that calculation on my calculator. So please find out how to do that on your own particular calculator. And when I press equals, there's the result. Now, there is another very straightforward way of doing that. Let me show you it. If I do my 6.1 divided by 100, which is the 6.1% as before, and multiply it by, let's just write that out as it is. So 3.27 times 10 to the power. Now, on my calculator, there it is. That's the power button. You will have a similar button in your calculator. It might not quite look the same, but it serves a similar function. Raised to the power, so I press that, and up pops the power. I have to have a negative, that's this button again, negative 22 to go in there. And that should give me precisely the same as I had before. And there it is. So there's several ways that you may want to do this. So 1.9947 times 10 to the negative 23. And that's grams. Now, they haven't asked for any accuracy. Sometimes it's the case that if you're given a number to 3 significant figures, as in here, that we would round this to 3 significant figures, which would be 1.99, chopping the 4 off. This just stays the same. But we'd have to explain what we're doing, but you'll get full marks for that previous answer. So in this case I'm doing it to 3 significant figures. So here's question 4. We're given the weights in kilograms of a sample of rugby players in Scotland. There's 7 weights given in kilograms. We have to calculate in part A the mean and the standard deviation of these weights. Now, on your formula sheet that you're given in the exam, you'll find 2 formulae for the standard deviation. I'm just going to use this one. Various letters in there, the X, just as a short way of standing for any of these numbers. X bar is the mean. Add them all up and divide, in this case, by 7. There's 7 of them. That would be the mean of these data values, these numbers. Square them. Sigma means add that all up. And then N in there is just that 7, the number of weights that were given. And there's a square root, and S stands for standard deviation. So we're going to arrange this. We must show our working in a case like this. We'll arrange this in table form. So the first column will head by X, and we'll transfer these weights into a column. So it's 93, 103, 99, 105, 88, 106, and finally 92. And to get the mean, we're going to add these up. So this will be sigma x. Just find what the sum of all these numbers are. So let's do that. There's 93 plus 103 plus 99 plus 105 plus 88, add 106, and finally we'll add the 92 equals, and there we go, 686. So, how do we get the mean? Well, the mean will be calculated by that total, all the sum of these 7 numbers, divided by 7. So we've got 686 divided by 7. So let's see what that gives us. So that's that answer, the 686, that answer divided by 7. And that equals 98. So that's our mean, 98. Now, let's go back to this formula. X minus X bar, X minus X bar. That's the next column in our table. That's the differences between these numbers and this 98 mean. So we've got 93 minus 98. That's negative 5. 103 minus 98. That's 5. We've got 99 minus 98. That's 1. 105 minus 98. 7. 88 minus 98. That's negative 10. 106 minus 98. That's 8. And 92 minus 98. That's negative 6. So what's next? We're told that we must add up all the squares of these deviations from the mean. So that's the next column. It's these deviations that we've just discovered, and we square them. So negative 5 times negative 5 is 25. 5 squared is 25. 1 squared is 1. 7 squared is 49. Negative 10 times negative 10 is 100. 8 squared is 64. Negative 6 squared is 36. These should all be positive numbers. And the formula tells us we have to add these up. So the total of all the squares of the deviations of these numbers from their mean. So let's add up all this. 25 is 50, 49 and 1 is 50, 50 and 50 is 100, that's 200, 264, 290, 300. You check that on your calculator. So how do we find the standard deviation? Well, a standard deviation will be the square root of this 300, the sigma x minus x bar all squared, sum of the squares of the deviation from the mean, divided by 1 less than the number of data points that we've got. So we had 7 numbers. 7 minus 1 is 6. So that's what we have to work out, and that will give us the standard deviation. So 300 divided by 6 that equals 50. We now need the square root of that answer. So that's the square root of 50, and that equals 7.071 and so on. Now approximately, it doesn't tell us what accuracy they want, but 7.07, and that's to 3 significant figures. So there we have it. That's the standard deviation, and the mean, we might as well make sure that the mean is stated. So that's your mean, and that's the standard deviation. So that's part A of the question completed. So moving on to part B of the question, we're asked to compare the weights of French rugby players compared to these Scottish rugby players, and we're told their mean weight's 105 kilograms and the standard deviation is 5.9 kilograms, to make two valid comments comparing these. So this is part B, there's part A. So we've got Scottish and we've now got French players, and we know about their means. The Scottish players, 98, we should have had measurements in there, they're both kilograms. So the Scottish mean weight, 98 kilograms, compared to the French mean weight, we're now told is 105. You'll notice that they're heavier on average, and the standard deviation, we'd worked out 7.07 kilograms for the Scottish, and we're told that the French standard deviation 5.9, so that's less. So the weights are less spread out about the mean for the French. Now, how do we compare these? How do we write statements? Well, let's have a look at what we might say. I've basically got three alternatives here. So the first option here, where we're saying the means, we can say that the French rugby players have a higher average weight, that's 105 kilograms, than the Scottish players, which is only 98 kilograms. Or another way of saying, on average, the French players are 7 kilograms heavier than the Scottish players. That's taking away 98 from 105, gets 7 kilograms heavier. So either of these would be fine. There's a second option with the standard deviation comparison, so second statement. The Scottish players have greater variation. Now, the 7.1 kilograms, that's the variation about the mean of 98, so they're more spread out. There's greater variation among the weights compared to the French players. Standard deviation's 5.9 kilograms. Another way of saying that is the French players have more consistent weights, or if you're talking about the Scottish players, there is less consistency in the Scottish players' weights. And the third option there is just combining these together. French players are heavier on average. We could maybe put the weights in there, the mean weights, the 98 and 105, but have more consistent weights, and then put in the standard deviation numbers. And Scottish players are lighter on average with greater variation in their weights. But I think statements should really be supported by the numbers that you're using to justify these statements. So here's question 5. We're asked to express this quadratic, x squared plus 10x plus 19, in this form. Now, what this form is telling us is that we need a couple of brackets multiplied together that are identical, and then another number, which may well be negative. Add a number or subtract a number at the end. So we'll attempt to do this. Now, you have various ways. We know that there's an x and an x. We're asked plus, put a number in here. Various ways of multiplying this. If we do firsts, outsides, insides, lasts, then we know that the insides and the outsides. Now remember, this number is identical to this, so we've got so many x's, and the same number of x's will give us this middle term 10x. And I think we can see there that it's x plus 5 times x plus 5 that'll do the trick. Now if you do this by the table method, then it's exactly the same, that we've got so many x and the same number of x added, these two added together, giving us that 10x. So it's 5x plus 5x will give us this 10x. Now unfortunately, when you multiply this out, we now know we get x squared plus 10x, but look at the last term. 5 times 5 is 25. Now up in the table method, 5 times 5 is 25. Now that is not 25, it's 19. We would have to take 6 away to get 19. So that's what we do. We adjust it by adding -6 at the end. So we've got x plus 5 times x plus 5, that gives us x squared plus 10x plus 25. We adjust it by subtracting 6 to produce that 19 at the end. So our final answer would be x plus 5. We leave it in this form. So we've got x plus 5 all squared minus 6. So b is -6. Well, here's question 6. We're told that this party hat is made up from the shape of a cone as shown. A piece of card is used to make that. There's a sector of a circle. Angle at the centre is 170 degrees. Radius of this sector is 15 centimetres. And we have to calculate the area of that sector. So here's another diagram. Let's complete the whole circle. Now we can find the area of the whole circle because we know the formula is pi r squared for the area of a circle. It's pi r squared. So that would be pi times, in this case the radius is 15. So pi times 15 squared, and we can work that out. But this is not the area of a whole circle. The angle at the centre is 170. It's now the complete circle has an angle of 360 degrees at the centre. So the area of the sector will be a fraction of that circle, and it will be 170 compared to 360. 170 over 360, that fraction of the circle. So that's the calculation that we're going to have to do. So let's bring on the calculator. Here it is. And let's just go ahead straight away with that. So it's 170, and we're dividing that by 360. We then multiply by pi. Now my calculator pi is there. I need to do this shift and then press that button. And there's times pi appearing in there, and then times 15 squared. So times 15, and most calculators have a square button. There's mine. And that's the calculation. So pressing the equals to see what's the final answer. And there we have it. It's 333.79, and so it goes on. Now the question asks us just for the area of the sector. It doesn't tell us what accuracy to do that. We usually end up just with 3 significant figures. So that would be approximately 1, 2, 3, and we're chopping the 7 off, so let's round it to 334 units. It's an area we've found, so the lengths were centimetres, the area would be centimetres squared. And we'd better see what we've done after vandalising that number. We've rounded it off to 3 significant figures. So 334 square centimetres. Well, here we have question 7. And we're shown a diagram which has a regular pentagon in it. It would appear that this side BA has been extended as a straight line up to point F, and a triangle created where this angle is 65 degrees. Now the question asks us to find the size of angle FEA. That's this angle down here. So it's a diagram where we have to angle chase. We have to just fill in as many angles as we possibly can. So let's start that fun process. So the first thing we know, in a regular pentagon, if we look at this point in the centre, the angles round about this point must be equal. And we know there's 360 degrees round this point here. Let's divide 360 by 5. Now 5 into 360 goes 72. So each of these angles round this point will be 72 degrees. Now you should check that on your calculators. You're allowed to use your calculator in this paper. Check that 5 72s, 5 lots of 72, does indeed give you 360. So there's a whole bunch of angles we've got. Now what else do we know in this diagram? Well, we know that from the centre out to each of these vertices, the distance will be the same. All of these lines, you can imagine a circle containing that regular pentagon. These would be equal radii out from the centre to the circumference of the circle. So that means we have 1, 2, 3, 4, 5 isosceles triangles. Now in an isosceles triangle, these two angles, that's the ones opposite the two equal sides, will be equal. So how do we find what these two angles equal? Well, the 3 angles in that triangle add up to 180. So if we take 72 away from 180, we'll get the sum of these two angles. So there's a second calculation, 180 minus 72. And that gives us 108. So what we know now is that the sum of these two angles is 108 degrees. Now I suppose that's true of all these triangles. They're all congruent triangles, they're all identical. You can place each one on top of the other one and they'll fit exactly. So the sum of two dots, 108. Well look, there's two dots. This must be 108. How do we find this angle? Well, remember we said that BA extends out to F in a straight line, so that these 3 angles around A must add up to 180. So if 2 of them are 108, we take 108 away from 180. 108 away from 180, and we're back to our 72 again. So this angle in here, 72 degrees. How do we find this angle that we're after? Add up the 65 and the 72, take it away from 180, and that will give you the third angle in this triangle FAE. So there's a another calculation we do, 180, and we take away the sum of 65 and 72 from that. Now 65 and 72, 137. Now you use your calculator to get these figures if you're not sure of your mental arithmetic. And if we take 137 away from 180, we get 43. So this angle, and the answer to this question, will be 43 degrees. So we can say angle FEA is equal to 43 degrees. I'd like to show you an alternative method of finding the size of this angle at A. And it's a beautiful way of finding the size of that angle. You notice there's 5 triangles in this regular pentagon. Each triangle, the sum of its 3 angles is 180 degrees. So the total sum of all the angles in these 5 triangles will be 5 times 180 degrees. Now we know that the 5 angles around here, the centre, add up to 360. So if we take away the sum of these 5 angles, this calculation will give us the total of these 5 internal angles of the regular pentagon. That's the 10 angles of these triangles. The sum of these will be the 5 lots of 180 minus the 360 at the centre. Now to do this calculation, 5 lots of 180, 360 is 2 lots of 180. So we'll basically have 5 lots of 180 minus 2 lots of 180. That's 3 lots of 180. Now you'll notice that that's the sum of all these 5 equal angles on the inside of that regular pentagon. And you'll notice that, therefore, if we divide this by 5, or take a fifth of it, that will give us the size of this angle at vertex A. Now that's 3/5 of 180. And if you work that out on your calculator, you'll get 108 for the inside angle of this regular pentagon. And that's exactly the same as what we got before. A lovely method, and very different from the previous method. So here's question 8, and we're shown a cuboid, and it's sitting on a X, Y and Z axis, and we're told 2 of the coordinates of the vertices. We're told this point L at the back of the cuboid has coordinates 0, 3, 12, and we're told that this point R here at the front on the x-axis has coordinates 4, 0, 0. We're asked to write down the coordinates of this vertex up here, M. So if we look at our 4, 0, 0 x, y, z axes, that's the order the coordinates are in, we seem to have 4 along the x-axis, so this line OR is 4 units long. Now if we look at this point L, 0 for x-axis, in other words we don't move along the x-axis to get to this point L, we do move 3 units along the y-axis, followed by 12 units up the z-axis. So 3 units along the y-axis, OP would be 3, and then PL up to there would be 12. So you can imagine numbers being put in these axes. We'll have a scale with this reaching 4, have a scale along the y with this sitting on 3, and then a scale on the z-axis with L and presumably K, because it's a cuboid, would be sitting at the number 12. Let's see that in closer detail. So here we have a picture of the cuboid, and you can see I've got scales along the X, Y and Z axis with 4s and 3s and 12s appearing. And it is a three-dimensional picture. There it is spinning round. It gives you a better sense of how that two-dimensional picture represents a three-dimensional cuboid. So there we have more or less the picture as it is in the question. So to find the coordinates of this point M, along the x-axis, let's start at the origin, we go 4 units, we reach the point R there. And remember, we're trying to get up to M, so 4 units along the x-axis, 3 units parallel to the y-axis, and then 12 units up parallel to the z-axis. So coordinates are 4, 3, 12. So there's your answer to part A. Let's return to the actual question and just put in that answer. And then let's move on to part B now. In part B it says we have to calculate the length of the space diagonal O up to M. Well, again, let's have a look at this in more detail on another diagram. So here we have the diagram that we had before, where the cuboid is sitting on the axes and the scales are in there with the 4 and the 3 and the 12. Now here's the space diagonal that we're asked to calculate the length of. And it would be nice if we could see right-angled triangles that might help us. Obviously Pythagoras would be of use when we have right-angled triangles. Now let's move this around, just get a feel for the look of the thing. No right-angled triangles available, but I think if we drew in that line OQ on the bottom face and then moved it around, I think we can find there's a beautiful right-angled triangle, OMQ, and then if we look right down on it, there's another right-angled triangle. So there are a couple of right-angled triangles that we could use there. So let's try that. Let's go back to the question, see if we can extract these triangles out of this diagram and do some calculations. So here's the original question, and let's introduce the other diagram that we were using. And remember, in this diagram we managed to move the cuboid around so that we had a face-on view of triangle OQM. And then we moved the diagram around so we were looking straight down on the cuboid from the top, and we saw ORQ. So let's work with these two triangles. That's the one at the base here, this one here, and the upright one, that's this one here. So let's work with this small triangle first. Let's take that triangle out of that diagram and put it there. So what do we know about this triangle? Well, we know that's a right angle, and we also know that the side OR, that's this side here, that's the side OR that was sitting along the x-axis, has 4 units in length. And we also know that RQ, that's this side here, RQ, was of length 3 units. That's the one that goes parallel to the y-axis. And those of you that are familiar with right-angled triangles recognise this as a 3, 4, 5 triangle. But we'll just show the working for that. OQ squared would be 4 squared plus 3 squared. That's Pythagoras' theorem. And that's 16 plus 9, which is 25. Square root of 25 is 5. So OQ is length 5. Now that helps us because OQ is the length of this side here in the upright triangle. There's OQ in this diagram. There's the upright triangle. And what do we know about this triangle? Well, this we know is a right angle. We've already worked out that OQ, that's this side here, is 5 units long. We know that QM, that's the height of this triangle, QM, this is the one that goes up the z-axis, and it reaches 12 units. So QM is 12. And again, if you're familiar with right-angled triangles, you'll recognise this is a 5, 12, 13 triangle. But again, let's show the working to this. So OM squared will be 5 squared plus 12 squared. So that's 25 plus 144. Calculators if you need them, which is 169. And the square root of 169 is 13. Now OM is the space diagonal that we're after, the length we were asked for in the question. So OM is equal to 13 units. So here's question 9. We're asked to change the subject of this formula. At present the subject is B, and we're asked to change it to K. So this involves getting K on its own, isolating K and getting rid of all the rubbish that's round about it. And we do this by normal balancing equation. So what we do to the left hand side we do to the right hand side to keep the balance equal. So first of all, let's have a look at this negative or minus 3c. The opposite of taking away 3c would be adding 3c. So to the right hand side we could add 3c, and obviously we must do that to the left hand side of this equation. And if we do that, on the left we'll get b plus 3c. And then on the right, adding 3c to this negative 3c, it just vanishes, and we're just left with 1/4 of kc squared. So in our attempt to get k on its own, we have got rid of this minus 3c. Well, what's next? Let's tackle this divide by 4. Opposite of dividing by 4, this quarter, divide by 4, would be multiplying by 4. And if I do that to the right hand side, I must do that to the whole of the left hand side. So let's try and do that. So 4 lots of the whole of the left hand side. We'll have to put that into brackets. We could also do 4b plus 4 lots of 3c, which would be 12c. That's what you get when you multiply out these brackets. But that's okay just now, 4 lots of b plus 3c. And we're multiplying this side by 4 to get rid of that divide by 4. So we're left with this 1 times kc squared. 4 lots of a quarter is 1. 1 times kc squared is just kc squared. So we're moving forward. Now what's next? Finally got to get rid of this times c squared. Now the opposite of multiplying by c squared would be dividing by c squared. So we'll take the right hand side and do that to get rid of this times c squared, and of course we'll divide the whole of the left hand side by c squared. So let's get that done. So we take the whole of the left hand side and divide by c squared. Whole of the right hand side divided by c squared, that times c squared vanishes, and we're left with k. And we've really achieved what we're asked to achieve. Normally, as we've been given this b equals, we put the letter on the left. So to find k, this is the formula we would use: 4 lots of b plus 3c divided by c squared. Now there are other ways of dealing with this. I'll just show you one of them, and that would involve multiplying both sides by 4 at the outset. So take this left hand side by 4 and the whole of the right hand side by 4. So what do we get? We get 4b, and then 4 lots of a quarter kc squared would give us 1 kc squared, and 4 lots of negative 3c would be negative 12c. And then we'd proceed as we did before, but in this case we would add 12c to both sides to balance that out. So left hand side would get 4b plus 12c, right hand side the negative 12c disappears, get kc squared, and then we divide both sides by c squared. So in effect it's the same as what we did before, except we're multiplying out these brackets. So there we go, we'll be left with k and 4b plus 12c divided by c squared, and write it with the letter on the left. So here's question 10. We're talking about a lorry. It's Bob's lorry. Has paving slabs and edging blocks on it. 7 stacks of paving slabs, 3 stacks of edging blocks, and we're told total weight of the load in his lorry is 2,400 kilograms. P kilograms is the weight of a stack of paving slabs. Remember there's 7 of them. And E is the weight in kilograms of a stack of edging blocks, and there's 3 of them. And we have to write down an equation in P and E to illustrate this information. So if a weight of a stack of paving slabs is P, and there's 7 of them, the total weight on his lorry will be 7p for the paving slabs. And if E is the weight in kilograms of a stack of edging blocks, and there's 3 of them, 3 lots of E, 3 times E, will have to be added to that to get the total weight of 2,400. So that illustrates that piece of information. Let's move on to part B, and this time different lorry driven by Imran. 3 stacks of paving slabs, 4 stacks of edging blocks, total this time 1,300. So we'll do a similar equation. This time we have 3 lots of P plus 4 lots of E, coming to a grand total of 1,300. Now, part C. Beth, driving a lorry, I presume. Her lorry, yep. 6 stacks paving slabs, 5 stacks of edging blocks. What's the total weight this time? Now, from these two equations, we can work out the weight of 1 stack of paving slabs and 1 stack of edging blocks. And from that, we would be able to work out the total weight on Beth's lorry. So we've basically to solve this system of equations, simultaneous equations. And remember, the way we do this is either to get the letter E with the same number at the front or the letter P with the same number at the front. We'll tackle it by getting 12E by multiplying the first equation by 4 and the second equation by 3. So let's do that. Let's multiply both sides of equation 1 by 4. So 4 sevens are 28. 4 threes are 12. That's both terms to be multiplied by 4. And then 4 lots of 2,400. Now you do have a calculator, so 9,600. You should use your calculator just to double check that. And the same for second equation, but this time multiplying everything by 3. 3 lots of 3p be 9p, and 3 lots of 4e would be 12e. And 3 lots of 1,300 be 3,900. Now, let's now subtract, because we have 12e in both of these, and the signs are the same, so we would subtract the second equation from the first equation to do the trick. Because this way you'll get rid of e and only have an equation with a letter p in it. So 9 from 28 is 19, so 19p. 12e from 12e is 0. 3,900 from 9,600 would be 5,700. Again, use your calculator for that. And then to find p, what do? We divide both sides of this equation by 19. And you'll discover that that goes 300 times. 3 19s are 57. So p is 300. We'll now substitute that. Let's use the second equation here, this one. So we'll substitute p equals 300 in that equation up here. So instead of 3 times p, we'll have 3 times 300. Add 4e, and we'll get 1,300. So 3 lots of 300 is 900. And what do? We subtract 900 from both sides to get 4e on its own. 900 from 1,300 is 400. And now divide both sides by 4. E will be 4 into 400 is 100. So we have our values for P and E. We're asked to calculate the total weight on Beth's lorry: 6 stacks of paving slabs, 5 stacks of edging blocks. That now we know is going to be 6 times 300 plus 5 times 100. Now 6 lots of 300, 1,800. 5 lots of 100 is 500. That comes to 2,300. But remember, do check using your calculator. So the total weight on Beth's lorry, this is us answering the question now, is 2,300 kilograms. So here we have question 11, and we're shown a diagram of two model aircraft. They're told they're mathematically similar. Now the small model is 14 centimetres long and the large model is 31.5 centimetres long. But we're concerned about the areas of the wings, and we're told the area of one of the wings in the small model, and we're asked to find the corresponding area of the wing in the larger model. Now let's just have a little talk about lengths and areas. If we have a length of 1 and we double that length to 2, then the length scale factor is 2. We've doubled the length. But if we consider the area that goes with these lengths, there's an area of 1. But if we double the lengths, we get an area of 4. So whereas the length area scale factor, the length scale factor was 2, we doubled the lengths, the area scale factor has been multiplied by 4. And 4 is 2 squared. So the area scale factor is the square of the length scale factor. Let's do another little example. If we have, for instance, a length of 2 going to a length of 3, then the scale factor there for the lengths we've multiplied by 1.5. That's the whole length 2 plus a half of 2. That's another 1, that's 3. And you get your 1.5 by taking the larger number over the smaller number. If you're going from the smaller length to the larger length, your scale factor for length would be this larger 3 over the smaller length 2. So scale factor 1.5 for the lengths. Now how does that work for the areas? Well, we start out with an area of 4 and we end up, when we multiply by 1.5, we end up with an area of 9. Now according to what we've set up here, then our area scale factor should be 3 over 2 squared. Now that's 9 over 4. 4 into 9 goes 2 with 1/4 left over, 2 1/4. Well, let's figure that out. If we double an area of 4, 2 4s are 8, and 1/4 of that 4 is another 1. So 8 plus 1 gives us the 9 squares in there. So multiplying 4 by 9 over 4 gives us 9. Length scale factor squared to get the area scale factor. Now, the length scale factor, take the larger number divided by the smaller one, 31.5 over 14. That's the length scale factor. Well, let's write this down at the side. Length scale factor (31.5) over 14. The area scale factor, this area to this area, that'll be 31.5 over 14 squared. So the area scale factor in this case is 31.5 over 14 squared, whatever that comes to. So required area, the large area, large wing area in the larger model, will be got from the area of the small model area, which we know is 24. So the required area will be 24 times whatever this comes to, 31.5 over 14 squared. So there's the calculation. We'll need to bring on the calculator for that. So let's do that. 24 times, now in brackets we have 31.5 divided by 14. Let's close the brackets on that, and we have to square it. Now I do have a square button. You'll need to find where yours is. And what does that equal? 121.5. So the question says calculate the area of one wing on the large model. So the required area is 121.5. Measurements of length were centimetres. Area will be square centimetres. So here we have question 12, and we're given a diagram where A, B and C represent the positions of 3 checkpoints, and we're given various pieces of information about the distances and bearings of the checkpoints from each other. And we have to calculate the bearing of C from B. Now, before we proceed, let's remind ourselves what bearings mean. So here we have an illustration showing B due north of A. It would start out with a bearing of 0 degrees. Now bearings are taken in a clockwise direction, so let's move B round to being due east of A, which say that B has a bearing of 90 degrees from A. This angle in here is a right angled one. You'll notice in the question it's exactly what B is here. It's due east of A, so in here we must have a right angle. So let's move B further in the clockwise direction, and now we've got a situation that appears in the question where we're asked the bearing of C from B. Now, illustration would show that we should be expecting an answer just a little bit over 180 degrees for the bearing of C from B. But let's continue that. So that's a reminder of what bearings mean. So let's go back to the diagram. We now know, since B is due east of A, that's 90 degrees. Also, since these two north lines are parallel, this angle also is 90 degrees. Now we're required to find this clockwise angle bearing of C from B. So if we can find this angle in triangle ABC, we would be able to work out the bearing of C from B. So what do we know about this triangle ABC? Well, not a lot, 2 lengths, but we can find this angle. This whole angle is 131 degrees, and part of that 131 degrees is taken up by this right angle. So the angle at A we can find by subtracting 90 from 131. That'll give us 41 degrees for this angle in here. Okay, so let's have a look at triangle ABC and see if we can do some calculations in that triangle. What do we know so far? Well, we've already worked out that this angle A is of size 41 degrees. We know a couple of lengths there. This looks very much like the sine rule. On your formula sheet that you get during the exam, you'll find the sine rule there. And what these little letters mean, remember, is the side opposite angle A is called little a. The side opposite angle C is called little c. Side opposite angle B is called little b, but we don't know anything about that one. So it would appear that what we are going to use is A over sine A being equal to C over sine C. So let's write that down. So we'll use A over sine A equals C over sine C. So let's stick in values that we know. Little a we know is 200. Angle A we know is 41 degrees. Little c is 250 degrees, 250 meters, and sine C we don't know. So from this we should be able to work out what angle C eventually is. Let's get rid of this divide by sine C, multiply both sides by sine C. So on the top of this fraction we'll have 200 times sine C. That means on the right hand side sine C will disappear. Now at the same time we can multiply both sides by sine 41 degrees. That'll disappear and it'll appear as a multiplying the 250. So there's a slight rearrangement. Now if we divide both sides by 200 we'll manage to get sine C on its own. So 250 times sine 41 degrees divided by divided by 200. So there's the calculation that we're going to do. So we bring on the calculator. Here it is. And let's forge ahead with that. So 250 times the sine. Now, one of the problems using your calculator, it may not be in the correct mode. Mine is. It says here degrees. You just check that your own calculator is working in degrees and not in rads or grads. You should see a deg or a D on the display to tell you that you're in the correct mode. So assuming you're in the correct mode, then we put in 41. Close these brackets, so that's the top line, and then we divide, and we divide by 200. And that calculation gives us this figure here. So that's 0.82, and so it goes on. Now to find C, we have to get rid of the sine and get C on its own. Now how do we do that? Well, we do the opposite of sine, which is called sine, inverse sine, or sine to the minus 1. You should find out in your calculator how to undo the sine. I have to do a shift on my calculator and then press this button. And there we get sine to the minus 1. Now I want to copy this figure into the sine to the minus 1. So I'll use my ans key. That means the previous answer. And what does that give me? That equals 55.092, etc. for this angle C. Let's just put that in there, 55 degrees, roughly. So to find angle B, which is the aim of this, remember we're wanting to find this angle up here so that we can finally find this bearing of the point C from the point B. So the third angle in a triangle, the three angles add up to 180. So to get angle B, we would take 180 degrees and subtract the sum of the 41 degrees and this 55.09, etc. So let's do that on our calculators. So we get 180 and we'll subtract, and in brackets we'll put 41 plus the answer that we previously had, that's this 55.09. So I press the ANS key, close my brackets. That gives me 83.9. So 83.90, etc. So up here I can write in 83.9. So how do I work out the bearing of point C from point B? Well, the whole angle around this north arrow consists of 360 degrees. So if I take away 90 and also this 83.9 that I've just discovered from 360, I'll be left with the bearing that I'm after. So the bearing of C from B is equal to 360 degrees, and we'll subtract the sum of 90 and this 83.9. So let's finally do that on the calculator. So there's 360, and I'll subtract the sum of 90 plus that previous answer, that 83.9 and so on, close my brackets, and equals. And there we'd have it, 186.09. Now, three-figure bearings to the nearest degree. So 186 degrees. And remember we said that it should be slightly bigger than 180. Remember from the wee demonstration we had earlier, it was an angle that's slightly bigger than 180, which is what we have. So that all fits in nicely. Well, here's question 13, and we're asked to solve this equation. 5x plus 1 divided by 2 is equal to 4x over 3 plus 1. So I would imagine the first move we should make is to try and get away from these fractions, and we'll do it in a couple of stages. I think it's easier to see what's going on. So we'll multiply both sides by 2 to get rid of this divide by 2. So on the left hand side we'll just be left with a 5x plus 1, and on the right hand side, when we multiply by 2, we multiply both terms by 2, and multiplying a fraction by 2, the 2 would appear in the top line, so we'd be doubling 4x, which gives us 8x over 3. If you're not sure of that, think of 2 times 4x over 3. There's your 2. So it's doubling the top line. We leave the bottom line as it is. So 8x over 3 plus, and we must also multiply this 1 by 2. Multiply the whole of the right-hand side by 2. And then second stage in getting rid of the fractions would be to get rid of this divide by 3, and we do that by the opposite of dividing by 3, multiplying both sides by 3. So both terms in this get multiplied by 3. So we've got 3 lots of 5x, 3 lots of 1. Multiplying this term by 3, we'll get rid of that divide by 3, just leaving us the 8x. And multiplying the plus 2 by 3 gives us, add 6. Now, we need to rearrange things. This 8x, let's get rid of that. So we're taking away 8x from both sides, and at the same time we can get rid of this add 3 by subtracting 3, and do that to both sides. So what have we got after all this? 15x minus 8x would be 7x. The 3 minus the 3 vanishes. 8x minus 8x, that vanishes. 6 minus 3 is 3. And final stage, we get rid of this times 7 by dividing both sides by 7. That gets rid of this 7, so we'll get x on the left. 3 divided by 7, that's 3 sevenths. And there's the solution to this equation. So here we have question 14. We have a picture of a ride at a theme park. Here's a diagram showing the car that you'd climb into, and you rotate as is shown in the diagram. It rotates clockwise, and the height h of the car above the ground is given seemingly by this formula, where the angle in there goes from 0 up to 360. And we have to calculate the two values of x for which the height of the car is 13 metres above the ground. So we have h being equal to 13. And we also have the fact that h is 10 minus 8 cos x. So obviously 13 is equal to 10 minus 8 cos x. And we have this equation to solve. So let's first of all try and get cos x on its own. Let's add 8 cos x to both sides to get that in a positive sign before it. And let's subtract 13 from both sides. 10 minus 13 would be negative 3. And then let's divide both sides by 8. So there's a rearrangement to get the value of cos x. Now, we have cos x being a negative value. It's negative 3/8. There's two ways of approaching this. You might have been taught to use the graph, or you might have been taught to use a quadrant diagram. So we'll first of all have a closer look at the cosine graph to see what's going on here. So here's a cosine graph. Starts at 1, goes down to 0 when the angle is 90 degrees. Cosine of 90 is 0. It goes away down to negative 1. Cosine of 180 is negative 1. And then comes back, the values come back up to 0 when the angle is 270, and then back up to value of 1 when the angle is 360. Now, if the equation we're trying to solve is when is the cosine of x equal to 1, then we can see there's a value here when the angle is 0, and there's a value here when the angle is 360. If we're asking to solve when is the cosine of x equal to negative 1, then will be one solution, the angle will be 180. Likewise, if we have an equation cos x equals 0, 90 degrees, 270 degrees are the two angles that we would get for that equation there. Now this diagram, you can see, has 4 sections to it. That's the 4 quadrants. First quadrant angles 0 to 90, second quadrants 90 to 180, third quadrant angles 180 to 270, and fourth quadrant angles 270 to 360. And you can tell from this graph that the values of the cosine are positive, they're above the x-axis in the first quadrant and the fourth quadrant. In the second and third quadrants, the values of cosine are negative. Now let's have a look at the diagram when we solve the equation cos x equals 0.5. There's the values of 0.5, and there's 2 solutions. One of them in the first quadrant, the cosine of 60 has a value of 1/2. The cosine is positive in the fourth quadrant. The corresponding angle here would be 360 minus that 60 degrees to get an angle of 300. So if we're solving the equation cos x equals 0.5, 2 solutions, 60 and 300. First quadrant, fourth quadrant. Suppose we're trying to solve cos x equals negative 0.5. 2 solutions, second quadrant, third quadrant. And how do we get them? Well, if we know the first quadrant angle is 60, to get the second quadrant angle, we take 180 and subtract 60, and we get a value of 120. For the third quadrant, we take the 180 and add the first quadrant value of 60 degrees to it to get 240. So the solutions to the equation cos x equals negative 1/2, second and third quadrants. The first quadrant angle solution is 60, that's cosine of 60 is positive 1/2. We then take the 60 away from 180 and add it to the 180. Now the question we're asked to solve is cos x equals negative 3/8. Now that's roughly negative 0.4. Not quite 0.4, it's 0.375. But here we have approximately the 2 solutions, second, third quadrant angles. So what our solution strategy will be is to say, well, okay, let's find the first quadrant angle. Let's solve when is the cosine of x equal to 3/8. Find that angle, and then to get the required second quadrant angle, take it away from 180. To get the required third quadrant angle, we'll add it to 180. So that's the strategy we'll use. Solve cos x equals 3/8 to get the first quadrant angle, and then for the solutions we want, take it away from 180 and add it to 180 to get the second and third quadrant negative 3/8 solutions. So let's solve this by using the calculator. And to solve an equation like this, we don't use the cosine button. We're trying to get rid of this cosine and just find what x is. We would use the inverse of cosine to both sides. So the inverse of cosine on this side would vanish that. We're left with x equals, and the cos to the -1, or the inverse cosine of 3/8. Now in my calculator, inverse cosine is here, cos to the -1, it's labelled as, and I have to press the shift button to get hold of that. And when I do that, I then put 3/8. So I've now got the angle whose cosine is 3/8. That's how you'd read this expression. Now again, make sure that the mode of your calculator is in degrees, not grad or rad. Change the mode so that deg is showing on your display. So assuming you're in the correct mode, we press equals now, and the angle we're talking about, the first quadrant angle, is 67.97 and so on. That's roughly 68. So that's the first quadrant angle. But remember that we're solving an equation where the cosine is negative, and remember the graph demonstration we showed we should have an angle in the second and third quadrants. If you just use the cosine, the quadrant diagram, then you will use this, and where is the cosine negative? They're all positive here. Only the sine's positive, so the cosine's negative there. Only the tangent's positive there, so the cosine's negative there. The cosine's positive here. So again, second and third quadrants. And what do we do to find the second quadrant angle? We take it away from 180. So in here we have 180 minus the first quadrant angle. Third quadrant, 180 plus the first quadrant angle. That's what we showed on the graph when we discussed the graph. So for the second quadrant, it's 180 minus the 67.97 and so on. So let's go to the calculator and see what that gives us. 180 minus that answer that we had, and that gives us 112.02 and so on. And the third quadrant angle will get, now we can't use ants because ants would give us 112 there, so we'll just need to type in the 67.97. So it's 180, sorry, it's plus, this time plus the 67.975 and so on. We don't need to put the whole thing on because we'll be rounding it off. So we get 247.97 and so on. So the question asks us, calculate the two values of x for which the height is 13 meters. So the required values for x will be 112 approximately, or 248 if I round to three figures there, 0.9, this goes up to 248. So these are the two values for x. Cosine of 112 and the cosine of 248 will give us negative 3/8. And we should of course put in how accurate this is. We've rounded these off to 3 significant figures. So here's the final question in the paper, question 15. And we've got a diagram shown. We're told that DG represents the vector r, and we're told that G to E represents the vector s. We're also told that travelling from D to E is 3 times travelling from E to F, direction and distance 3 times. And we're asked to express G to F in terms of R and S. What does GF represent in terms of the vector R and S? And make sure that we've got it in its simplest form. So let's start off travelling from G to F. Now we won't go directly from G to F. Let's take the scenic route. The scenic route would go from G to D, followed by D to F. Now you notice that from G to D, that's okay, we can probably work out that. D to F, well, maybe we should split that up and have a cup of coffee at E. So let's do that. So we'll travel from G to D, and then we'll travel from D to E, have a bit of a rest, and then we'll continue our journey from E to F. Because after all, we know that E to F, well, we're told that from D to E is 3 times from E to F. So I think things are going to be okay here. So what do these journeys represent? So let's try G to D first of all. What does that represent in terms of the vectors? So let's do that journey. G ouch to D. Did you hear that? That arrow hurt. It's going in the wrong direction. So it doesn't represent R, it represents negative R. That ouch comes out as a negative. That's a significant pain. So going against the arrow introduces that negative. Now what else do we need? We need the journey from D to E. So let's have a look at D to E. And it doesn't, on the face of it, involve any of the vectors directly, but it does if we go a scenic route again, go to G and then back up to E. So we'll split this up into 2 journeys, the journey from D to G, followed by the journey from G to E. And what does that represent? Well, we know what that represents. Travelling from D to G represents R. There's no ouch, we're going with the arrow, plus or followed by S. So that represents R plus S. So that's okay. And we're now sitting looking at E, F. Now we know that D to E is 3 times E to F. Another way of saying that is that E to F is 1/3 of the journey from D to E. So from E to F, since it's 1/3 of the journey from D to E, that would represent 1/3 of what DE represents as R plus S. Well, my goodness, I think we have all the little bits of the journey and what they represent. So we can say that GF represents, well, let's write this down here, we won't have enough room up there to complete the question. GF represents GD, which is negative R, followed by DE, which represents R plus S, followed by EF. EF represents 1/3 of R plus S. And now we've got algebra to do, because these behave just as you would simplify them in algebra. So negative R plus R, that vanishes. They cancel each other out. We're left with S plus, let's multiply out these brackets, 1/3 R plus 1/3 S. So the final move is to say, well, what's S plus 1/3 of S? Well, the whole of S is 3/3 of S plus another 1/3 of S. That would be 4/3 of S. We've got 1 plus 1/3. That's 4/3. So it's 4/3 of S plus 1/3 R. And that's what the journey G to F represents in terms of the vectors S and R. So that's Mr. Corsi signing out, and I hope you enjoyed the video.